Hello, first grade families and friends. This is Miss Burns, and this lesson is for all first graders at Bethune. It is your day 2 math lesson of week 3 of TeleSchool. So for the last several days, we've been working on using objects and pictures to help us solve 2-digit addition problems. But so far, all of the addition we've been doing has been without regrouping. Today I'm going to talk to you about what regrouping is, and I'm going to show you how to use objects to do regrouping. So our standard is 1 NBT4. We're still in the same standard where we're adding 2-digit numbers. And today we're going to be adding 1-digit numbers to 2-digit numbers with regrouping. I can use objects, so we're going to be using base 10 blocks and ones, or if some of my friends remember from last week, they might have actually created their own base 10 blocks and ones. And we're going to use those objects to add a 1-digit number to a 2-digit number with regrouping. So let's talk for a second about regrouping before I show you what this math looks like. When we regroup, what we're doing is we're taking 10 ones and we're trading them for a 1 10. Now we've done this before. Let's pretend that we've got 12 straws. No, pretend we've got 12 straws here, and I'll count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all ones right now. They aren't grouped together. And we as good mathematicians know that it's much easier if you use what you know about place value and counting by tens to help you count things quickly and efficiently. So if I were to want to count these in a more efficient way, I would want to bundle or group 10 of these and trade them into a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that I've got 10 ones, I can put them together and bundle them to make a 10. So I've regrouped them or made them into a 10, so I can easily count to see that I have 10, 11, 12 straws. This is also true when we use ones. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ones. But I know that it's much more efficient if I use what I know about place value and counting by tens to count up objects. So instead of keeping these 10 ones, I'm going to regroup them. Notice how I put them or I arranged them into my imaginary 10 frame. And I'm going to swap them out for a 10. If I do this trade though, I have to remove these 10 ones. So now I originally had 12 ones. Now I have one group of 10 and 2 leftover ones. When we regroup, all we're doing is taking 10 ones and trading them for 1 10. This is a fair trade. I can put these 10 ones back and swap out my base 10 block. I can take these 10s and trade them for my base 10 block. They are equal. They mean the same thing. So we're going to use regrouping today when we are solving these problems because we're going to notice that in our problems, we're going to have a number bigger than 9 in our ones place. So let's take a look at what this might look like. So we're working on 2-digit addition with regrouping, remembering that when we are regrouping, we are trading 10 ones for 1 10. Just like when we worked on our problems last week, we can do 2-digit plus 1-digit or 2-digit plus 2-digit. For today, we're just worried about 2-digit numbers plus 1-digit numbers, or the reverse, 1-digit plus 2-digit. We know that the commutative property of addition tells us we can add in either direction. When we do this, we're going to follow almost the exact same procedure. We're going to line up our equation vertically. That's going to help us take advantage or show what we know about place value by inserting our place value chart. We're going to label our 10s, we're going to label our 1s. Then we are going to use objects today, like our base 10 blocks and our 1s, but you'll notice that on my anchor chart, I've drawn those in. 2 10s in 27, 7 leftover 1s. 1, 2, 3, 4, 5, 6, 7. Then I'm adding the number 5. Well, 5 doesn't have any 10s. It only has 5 ones. I drew 5 ones. But wait a minute. If I look at my ones here, I can regroup them. I can trade 10 ones for 1 10. So 7 plus 3 of the ones that are coming from my 5, I can regroup those and then trade them for a 10. Notice that I also crossed out that group of 10 ones as soon as I traded it in for my 10, being sure that I don't accidentally add all of those ones in a second time. Then all I do is go down my place value mat. I'm going to add down my place value mat. I've got now just 2 ones left over. Remember, I've regrouped and traded. And now 1, 2, 3 10s. 27 plus 5 is 32. Let's take a look at some more problems. This first one I'm going to do, and I want you to just watch. And the second and third problem you can actually do with me. Okay, so the first problem we're looking at is 28 plus 3. Now, you probably already know, because I've said it so often, that the first thing I'm going to do to make this problem easier for myself is to write it vertically. I'm changing it from horizontally, going side to side, to vertically going up and down, because that's going to help me use what I know about place value to add. So I'm going to go ahead and insert my place value chart. I know I'm writing T for 10s, O for 1s. Just like I solved these problems last week, I'm then going to go ahead and grab my objects. Today we're using objects like base 10 blocks and 1s to help us solve these problems. So I'm going to start at my 10s place, and I know that the number 28 has 2 10s. Here are the 2 10s for 28. It also has 8 leftover 1s. Well, I remember that I should probably try to set these up in an imaginary 10 frame, because that's going to help me see if I can regroup. So I've got 1, 2, 3, 4, 5, 6, 7, 8 1s. 2 10s and 8 1s gives me my first addend, which is 28. And then my second addend is 3. Well, 3 doesn't have any 10s, but it does have 3 1s. I'm going to grab my 3 1s, setting them up in my imaginary 10 frame. Well, my anchor chart says I'm going to add the 1s, and I need to see if I can regroup and trade for another 10. Well, when I look at my 1s, I notice that my 8 1s from 28 are missing 2 buddies or 2 1s up here that could help me fill in that invisible 10 frame. If I take 2 1s from 3, that will help me fill in that invisible 10 frame. And look, now I've regrouped. Now I'm able to take these 10 1s up here and trade them for a 10, making sure that we actually remove my 10 1s from my work. Now I'm just placing down my 10, and I have 1 1 left over. Now I can move down my place value chart and add. Well, now I just have 1 1 because I regrouped and traded 10 1s for my 10. And instead of having 2 10s, now I actually have 3 10s. Remembering that these 2 10s came from 28, this 10 came from my regrouping. So 28 plus 3 is 31. All right, we're going to try another problem. This time I want you to follow along with me and see if you can actually solve some of this with your manipulatives or your objects as I move. Okay, erase and give ourselves some space. Our next problem is 17 plus 5. You know that the first thing you're going to want to do is set this up vertically. By setting up our equation or our problem vertically, we're going to be able to show what we know about place value to help us solve. We're then inserting your place value chart. T stands for 10. What are we going to write for 1s? You got it, O for 1s. Okay, now let's look back at our chart. Once we set this up, We know we're going to have to add our ones, moving down our place value chart. But before we can add up all of our ones, we also want to see if we can regroup and trade 10 of those ones to get another 10. Then we'll add our 10s. Let's see what happens here. Okay, so we're going to set up 17. 17 has how many groups of 10? Well, if I look in my place value chart, 17 has one group of 10. I'm going to show that one group of 10. How many ones does 17 have? You're right, it's 7. So I'm going to grab my 7 ones and I'm going to set them up as if they are inside of an invisible 10 frame. There's my 7 ones. My 1 10 and 7 ones is showing 17. Now let's look at our second addend. Our second addend is 5. Does 5 have any 10s? No, you're right, it doesn't have any 10s, but it does have 5 leftover ones. And we can go ahead and set those up inside of an invisible 10 frame. Now our chart told us that we're going to move down our place value chart and add our ones and see if we can regroup and trade. Well, is there any way that we can regroup our ones so that we can trade or swap 10 ones for 1 10? Let's see. Well, we have 7 ones here, and if I move some of my ones from 5 with my 7, I'm able to make a 10. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But instead of keeping those 10 ones up there, what can I do? You're right, I can trade them. I've regrouped, now I'm going to trade. Now I'm going to take these 10 ones and I'm going to swap or trade them. We're getting rid of these because we are replacing them with a 10. Now I can continue adding. I'm left with 2 ones. And how many 10s? 1, 2 10s. So 17 plus 5 must equal 22, or 2 groups of 10 and 2 leftover ones. Nice job, friends. Let's try one more together. Okay, our last problem. We want to know what's 33 plus 9, and we're going to use our objects to help us. So our first step is to rewrite our problem, and we're going to write it vertically or up and down. That's helping us show what we know about place value. We're going to go ahead and drop in our place value chart. I'm labeling my 10s place with a T for 10s, my 1s place with an O for 1s. Now, we're using objects to solve our addition problems today, so now is my chance to go back in with my base 10 blocks and 1s to represent these numbers. So, 33 is my first addend. I need to show my 3 10s that are in 33. Well, here they are. 1, 2, 3. Now let's show our 3 1s. 1, 2, 3. Our next addend is 9. How many 10s does 9 have? Good, you didn't let me trick you. 9 doesn't have any 10s. Instead, it has 9 leftover 1s. So let's set up our 9 leftover 1s inside of that invisible 10 frame. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we've represented our addition problem with objects. Now we're going to add. But wait a minute. Before we add everything up, we're going to take a look at our 1s and we're going to see if we can regroup and trade. Let's check it out. Can I regroup or rearrange any of my 1s to be able to make a full 10 with 10 1s in it? Well, I see 9 1s right here. It's only missing another 1 in order to make it a 10. So if I take this 1 from the 3 and move it down here, Now I've actually got 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Instead of keeping those 10 ones in my ones place, I want to trade them for a 10. Remembering to move them off of my board. And I'm just swapping them out for a 10. Now I can move down my place value chart and add. Well, now this is really easy. I've got 2 ones left and 1, 2, 3, 4 10s. So 33 plus 9 equals 42, or 4 groups of 10 and 2 leftover ones. So remember, friends, that today we're working on 2-digit addition with regrouping. And regrouping, all that means is that we're trading 10 ones for 1 10. Be sure that when you're solving these problems that you actually remember to move those 10 ones out of your way when you're making your trade. Otherwise, we're going to do our adding incorrectly. As soon as you do your trade, you find out how many ones you've got left and then add up all of your 10s. Your job today is to click right below the video, and you're going to be answering some addition problems that are going to ask you to use your objects to add a 1-digit number to a 2-digit number, and you're going to practice this doing regrouping. Tomorrow we will continue doing 2-digit addition with regrouping, but instead of using objects, we will do it with pictures. Thanks so much, friends. Catch you in the next one.